Welcome to calculating the gradient of a tangent and a normal to a curve. So just a reminder that differentiation finds the gradient of a tangent to a curve at a particular point. And the other introduction today we're going to look at is a normal. So a normal line is perpendicular to the tangent line. And we've learnt with lines that are perpendicular that their gradients multiply to equal -1. So the gradient of the tangent times the gradient of the normal equals -1. Or we can use the negative reciprocal rule that we've also learnt. So here's our example. We're going to calculate the gradient of the tangent when x equals 4. So we're doing the tangent first. So we've got our two lines, or our two curves, y equals x squared plus 5x, and y equals the square root of x. So for our first one, y equals x squared plus 5x. So you differentiate to find the gradient of the tangent. So we differentiate and we get 2x plus 5. At a particular point, so we know that x equals 4, so we sub the 4 in to where the x is, and we get 2 lots of 4 plus 5, which is 13. So the gradient of this tangent at the point 4 is 13. So the other one is just a variation on that, so it's just using a harder differentiation. So we change square root of x to the half. We bring the power down the front, so we differentiate by bringing the power down the front and lowering your power by 1. That's our differentiation. So to find the gradient of the tangent, we let x equal 4, or when x equals 4, substitute it in and we get a quarter. So the gradient of the tangent to this curve when x is 4 is a quarter. So let's apply the same concept but now with a normal. So the first thing you have to do is you've actually got to find the gradient of the tangent at the point. And then we'll use the negative reciprocal to find the gradient of the normal. So for our first curve, x squared minus 5x, the differential is 2x minus 5. When x equals 2, 2 times 2 minus 5 is -1. So the gradient of the tangent is -1. So the gradient of the normal, the negative reciprocal, is 1. For the curve 2 over x minus 1, rearrange it to 2 outside of x minus 1 to the power of -1. Differentiate, power down the front, lower your power by times by the differential inside, lowering your power by 1. So you end up with -2, x minus 1 to the -2. When x equals 2, you substitute that in, so the gradient of your tangent is -2, so the gradient of your normal is a half. Thank you.